In today's lesson, we are going to see an introduction to methods, to functions, and we are going to create our first class related to gaming. That will be the class player. Okay, first of all, in case that you don't have the progress we did yesterday, you can download it from this link. Okay, so we are going to see a short introduction to how the methods and functions work. I will put on the video description several links to tutorials where these concepts are way better explained. So this is going to be just a really quick introduction, just in order to get up to speed to start focusing in game-related programming stuff. So why do they exist, the methods and functions? Is that the reason is why sometimes we need to perform a certain functionality multiple times in multiple different places. That's why we are going to use the functions and methods to be able to perform some actions that needed to be repeated more than once in multiple different places in the code. What's the difference between a method and a function? It's pretty straightforward. The method doesn't return any value. Okay, the declaration of the method always starts with void, the name of the method, and a collection of data, of parameters that need the method in order to perform the action that it does. And the function returns a value. Okay, the syntax is almost the same. It only returns a value. Okay, it can be an integer, it can be a boolean, it can be a float, it can be anything, any type of value, but a value. The name of the function and also a collection of parameters in order for the code that it's inside the function to perform its function. So we are going straight to the point, and we are going to go to the code. Okay, so if you haven't already opened the project, just open it. Okay, and we are going to our script, controller script, and we are going to create a method, a function that is going to check if an object is inside or not the frustum. What we are going to check is if the object is visible. Okay, the camera frustum is just, let's see, the field of view that where we are going to check if that object is inside the camera, the frustum, if it's visible from the camera. So what you are going to do just right now is copy paste this function. Okay, and we are going to explain it. So what we are doing right here, first of all, we use the keyword private just to indicate that this method is going only to be used inside this the class, only here. We are not offering this code outside. Okay, and we specify that this function is going to return a boolean. Okay, because what we want from this function is to know if the object is visible or not. So it's going to return true if the object is visible, or false if the object it isn't visible. After the boolean, the return type boolean, we specified the name of the function. The name of the function follows a code convention that it's quite widely accepted, that it's start with in uppercase. Okay, and every time you define a word, you start again with uppercase. So we would starting with is, then visible, and then from. Each one is starting in uppercase. That's a code convention. As I told you before, there are multiple code conventions. Every team has code conventions. You have to get used to the code conventions decided by your team. Okay, next is the definition of the parameters. The parameters are the necessary data that you have to provide to the function or method in order to perform its operation. It's just a declaration of the data it needs. And so in what we are doing just in this case is we are specifying in this parameter of type bounds. If we look into the definition of bounds, it represents an axis aligned bounding box. So basically it represents just the bounding box in the 3D world space that will give you enough information to calculate if this object is inside the camera frustum, so it's visible. Okay, and the other parameter that we are going to use is the camera, the 3D camera, that we will get the properties in order for us to calculate if the object is visible for the camera. Inside this function, well, there are some functionalities that are called related to the calculation of the planes in order to calculate if the bounds are inside the geometry of the visibility of the camera, and well, we will get true or false depending if it's inside or not. The lesson here is not about to fully understand what mathematical operations are being calculated right here, but to understand that we declare a function just to be able to perform a certain functionality several times in different parts of the code. Okay, so once we have declared this first function, now it's time to use it. And we are going to use it just in the start method. Okay, so what we are going to do is, well, we are going to copy and paste this code, and we are going to explain it. We are going to copy and paste it just in the start function. Okay, so what are we doing here? What are we doing here is that just after we have finished of creating our cubes, we are checking if the recently created instance it's inside or not the camera frustum. That's it, if it's visible or not. So we call the function is visible from. We provide both parameters. In one side we provide the bounds. In order to get the bounds of the game object, we get the bounds through transform. We get the component renderer. The component renderer is mesh renderer. The component mesh renderer, we will see that it's a class that inherits from the class renderer. For the moment, just understand that we can get the component renderer, and from that component we can get the property bounds that will give us the information we need about the representation of this game object in the 3D space in order for the function is visible from to calculate if it's inside or not. Okay, finally, to get the camera of the system, there is this functionality of the system that allows us to get the main camera that it's being used right now, and we can get the camera that it's being used right now just by using the class camera dot main. We will be getting the first enable camera whose component is tagged as main camera. So with only that information we can get the camera. We will check that this condition is true, and if it's true, then we will show a log message telling us that okay, this object is visible. I mean, if it's not visible, we will say that it's not visible also in a log message. So let me restore a little bit to make it easier. Okay, so we are going back a little bit just to make it easier for us to see what game objects are visible and what not. So what we are going to get right now is just the row of cubes shifting in the x-axis. So we will see half of the instantiated game objects visible and half not. So we can better understand what's going on here. So okay, so we have done these changes. We can go to the Unity editor. And let me check where is the camera right now. Okay, the camera is pretty far away. Let's fix it. Okay, let's fix it a little bit. Let's move the camera, taking as a reference this cube that we will place in the 0, 0, 0. Okay. So with this cube as a reference, we are going to move the camera just right here. Okay, here we should be able to see half of the instantiated game objects and half not. So we are going to remove this reference. Okay, and now we can execute. Okay, so what's going on here? Right now we are able to see 1, 2, 3, 4 cubes. So if we check the log, okay, here we have all the messages. Let's disable the stats. So what do we have here? We have the first instance is visible, the second instance is visible, the third and the fourth were visible. Now that we have changed the size of the game of the screen, more cubes are visible, but since this code was only executed once in the start method, and the start method it was only execute the first time you run the application, we are only going to get just these messages. So the first 4 cubes were visible, and the other 6 were not. Okay, so let's pause and run again to make it more visible or more understandable. To clear the log, we just press clear here. Okay, so let's press play, and right now we are getting more cubes visible. So right now we are getting 1, 2, 3, 4, 5 cubes visible. Sorry, 6 cubes visible, and 4 cubes that are not visible. Okay, let's make some changes. Let's move the camera away so we can see all the cubes. So if we press play and we are not wrong, all the cubes, maybe it's too far away, but all the cubes are visible. Okay, so that's our first use of a function. We have declared the function. The function does some functionality. In this case, it checks if the object is visible. It's inside the camera frustum, and we were using this method, this function here. We call the function by its name. We specify the data it needs to perform its operation. It needs the bounds related to the component mesh renderer. Okay, we get the bounds, and with the bounds and the other parameter that is the camera, we can get the right functionality from our function. We check if it's true. Okay, if it's true, we display one log message. If it's not true, we display another log message. Still in the topic of the functions and methods, we are going to be introduced to recursivity. Maybe recursivity is a topic that could be complicated, especially at the beginning. And I advise you to check the links that I have provided in the description, just for you to practice and understand better the concept of recursivity. But trying to keep it simple and with an example, well, sometimes we may need to perform operations where we won't know exactly how many elements we need to modify or change. In order to do that, we have to our disposal the concept of recursivity. And we will try to understand a little bit the concept of recursivity through an example. So right now what I want you to do is just to copy and paste this code, and we are going to try to explain it. Okay, so let's go back to the controller script and let's paste this code right here. Okay, now it's time to analyze what's going on here. Okay, so what we have here, it's a private, something that it's going to be only used inside this class controller. Okay, void, in this case we are declaring a method. It's not going to return any value. We declare the name of this method, that it's called apply material on objects. For the moment we are going to ignore the body of the method. We are just going to focus on what we want from this method. What we want from this method is to apply a material on a game object and its childs. Okay, what means to apply a material? Okay, let's go back to the exercise we did yesterday. Okay, so do you remember that we used our image that we downloaded through internet, and we applied to the cubes? That means that we created a material automatically. When you drag an image and you drag it over a 3D object on a scene, it's created a material that well, it is applied to the game object. So with this function, what we want is that to specify a game object, and we want to go through all the game objects that can contain this game object and apply a specific material. For example, in this particular case would be that if we call the apply material on objects on this game object group of cubes, it will go through all the cubes, applying the material. Okay, so now let's restore the code and let's explain a little bit what's going on here. Okay, so the first instruction that we are running inside the body of our method, it's the instruction for each. For each, it's similar to also the instruction for, in the sense that it allows us to iterate. But in this case, it allows us to iterate for all the elements that are inside an array, a group of elements. And in this particular case, we are interested to know how many elements could have a game object in. For example, if we are checking how many elements has a group of cubes, it will get all these 5 items. Okay, so thanks to for each, we are able to use this syntax to go through all the childs existing inside a game object. So what would happen is that we will get this list, and we would go, we will get in each child, we would get each of the instances. So we get a child, and to the child we call again the method apply material on objects, the same method, we apply it again because we're interested to apply the material to all existing objects inside that game object. So we are applying again. So the first execution will go through the group of cubes. We'll check all the childs. Okay, I am checking all the childs, and for this first child, then we will call the apply material on objects again, and in the next execution of apply materials for this particular object, it will check if there are if this object has also childs that where it could apply the material. Let's imagine that we have childs that we can apply the material. To have childs that can be applied the material, so we would create, for example, just 3 childs of this one. Let's see where they have been placed. Okay, they are on 1, 1, 1. Okay, they are here. So let's move a little bit this cube. No, let's disable the mesh render. Okay, so we have here the different cubes. Let's make them a little bit smaller. 0, 5, 0, 5, both also 0, 5, 0, 5, and in different positions. Okay. So in the first iteration, we would go through all these childs, and in the next for this child, it will go through all of these childs, and if this one also had more childs, it will go through all these other childs. Okay. As I said, the concept of recursivity is not an easy concept to understand, especially when you are starting. So please just follow the tutorials, practice a little bit until you get it right. And there is no hurry to understand the recursivity. Don't worry too much of it for the moment. Okay, so for each child, we were also calling the apply materials to go through all the childs. Okay, so when we stop calling on apply materials, we stop when we don't have childs. That means that we have reached just an end. For example, this sphere doesn't have any childs unless we create another one, but this sphere will be an end node. Okay, if it doesn't have any childs, it will be an end node. So when we call for that particular sphere right here, it will check and it will say, okay, I don't have any childs, so I don't call anymore the apply on materials. Okay, so the next thing that is going to happen is to apply for sure that the reason why we are calling this function, that is to apply the material to the 3D object. So to apply the material, we first should check if we have a renderer component, because only if there is the component renderer, it's the object going to be visible in the 3D world. So we check that we have the renderer component, and in the renderer component we have the property material that will allow us to apply a material on this 3D object. The next step we are going to do, first of all, we are going to make sure that we are on the right scene. So go back to the bucles scene. Okay. And we can go back to the code. So we have created our recursive method that will apply a material to all the childs inside the game object that we specify as a parameter. And now we are going first to create a public member variable where we will place the reference to the material. Okay, so create a public member variable of type material and call it, for example, my material. Okay, once you have coded that, on the start method we are going to code this line. Okay, apply material on objects, and what we are going to specify is going to be the root of the whole scene. Okay, so we are going to specify the whole root of the scene, so it will go through all the game objects that are in the root, checking if for each of them if they have the renderer component, and if they have the renderer component they will apply the material that we have specified. So let's check what's going on here. So in order to get the root, we can do it through this way. So we access it to this to get the reference to this game object. We get the game object, we get the transform of this object, and transform has a property called root. The property root will give us what we want. We want just the root of the scene. Okay, so we are getting that information with root, and root is a transform, and since the apply materials on objects requires from the first parameter as to be a game object, we just get the game object linked with root, and then we apply the material. Okay, so what we need to do right now is going back to the editor. We are going to create a new folder in resources. We will call it materials. Okay, and inside materials we are going to right mouse click, create, and here we have an option of to create a material. Okay, so we will create our material, so my material. We are going to keep it simple. It's just a plain color, and we are going to choose whatever color we feel like. For example, I am going to choose red. Okay, so we have created our material, and now we can use it. So we are going to set our previously created public member variable my material with the material that we have created. Okay, and if everything works as it should, we save the scene, and when we press play we can see that all our cubes are in red. Okay, let's watch it on the scene. Okay, just right here, and we can see that all our cubes are in red. Okay, so why? Okay, as we have said, we are calling apply material on objects, and we are taking the root. That means at this level, we are checking for each game object in the root. We are checking all the game objects until we find out which one has mesh renderer to apply the material we have created, and that's what it happens. We have gone through all the elements, all its childs, and every time we have found a mesh renderer, we have applied the material. Okay, and that's the power of recursive functions. It allows you to apply a functionality to a number of elements that you don't know exactly how many they are. The main problem with functionality is that it can cause easily Stack Overflow if you are not careful enough when we are defining the ending condition. So For the moment, don't worry too much about recursivity. It's a topic that you will eventually see it again, and it will make sense when you have faced another challenges in game programming. On the next section of today's lesson, we are going to be introduced to object-oriented programming, and we are going to do it through a very basic example, just to create the game player class. And this game player class, we are going to be able to control it with the arrow keys plus the mouse. So first of all, I will put in the description links related to object-oriented programming tutorials. Right now we are going just to do the most basic thing and get up to speed with programming. Okay, so in object-oriented programming, a class is an extensible program code template for creating objects. Okay, and the class provides initial values to keep the state, what we call member variables, and implementations of behavior, what we call member functions or methods. So on one side we have variables where we keep the track of the state of the whole thing, and on the other side we provide a functionality that operates over these values to provide the behavior we are looking for. In the screen we can see a very basic definition of a class, in this case the class cycle. The class cycle has two variable members, that it's the radius of the cycle as a double and the color of the cycle as a string, and it provides a collection of methods to that operate over the previous member variables. Okay, and from this definition we can create instances. We can create 1, 2, 3, any number of instances that we want, and in each of these instances we can set different values for its properties of radius and color. We have here, for example, a radius of 2 and color blue, the same radius of 2 and color red, and here as a radius of 1, and we keep the color red. So this is just the most basic example of a class definition you could get. Related to gaming, we are going to start with one of the most essential classes in game programming, the class player. Beyond that, in future lessons we will understand the concept of inheritance, and we also will create the classes enemy and NPC. What you can see here, it's a pretty basic inheritance structure where there is the definition of the class avatar that contains some functionalities that are shared between all player, enemy and NPC, things like life, position, things that properties and methods that we will see that all these classes have in common. Okay, so we are going to create a player, okay, that we will be able to control in first person. So the first steps that we are going to do is we are going to create our scene. We are going to create a new scene. Then the scene we will call game. Next thing that we are going to do, let's go to the scripts folder, and we are going to create the script called player. Next thing that we are going to do is we are going to create a 3D plane on the game scene. Just check that you are on the right scene, the scene game, and now you can create a 3D plane. So we can create a 3D plane, 3D objects, plane, and scale it to a high number, for example 100. Okay, so we have a plane big enough in order for us to move. Now what we are going to do is we are going to look for a texture in the internet that we can apply to our flow in order for us to better identify when we are moving. So let's go to the internet, let's look for a texture, floor texture, and just choose one of the one that you like. For example, I am going to choose this one. Okay. And place the texture on the folder images. It's quite okay to place the texture. Okay. We have saved the texture on the folder images, and we have it right here, and we can just drag it and drop it on the plane. But well, right now the plane is huge, and the texture it's fully mapped just to the whole plane. But we are interested to have more precision, to have better repetition. A way to have better repetition for the texture is that there is a property in the material that it's called tilling. This property will allow us to just apply the texture on a much lower scale. So right now we are applying a tilling effect of 100. So if we go closer to the floor, we can see that the texture is being repeated plenty of times. That will help us when we are moving our player to identify that some movement is being performed. So next we are going to create on a scene a capsule, okay, and we will rename this capsule as player. Okay, we will create a capsule, we will place it just a little bit above the floor. Okay, rename it please plane as floor and the capsule as player. For the player we are going to place it just for the sake of placing it to the 000. Okay, let's center the whole thing. Let's find out where the camera is. Okay, good. And the plane, it seems that the plane is too far below, so we are going to move the plane a little bit until, okay, that looks better. Okay, that looks better. Okay, next we are going to add a rigid body to this this game object player. Okay, so we are going to add a component, a rigid body, and on the constraint section we are going to freeze the rotation on all the axes. Okay, we are going to freeze the rotation. What will happen here is that the rigid body is just a component that we can add to a game object in order to perform physics in the 3D world. Without this restriction right here, what would happen is that since this is a capsule, and well, the capsule, it has just it will just balance when it touches the floor, and it will fall. So we are not interested for that to happen. And also we are not interested to use another shape, because eventually we will want that to climb stairs and ramps, and other shape could prove difficult to use in order to do that operation. That's the reason why we are choosing the capsule as the player. Okay, so next what we are going to do is we are going to move the camera just inside the game player object. Okay, so we are going to pick the camera, move it inside, and we are going to reset the camera to 000. So we have this option right here to reset. Okay, And what it does, this reset function, it resets the position in relationship with the object which is inside. Okay, so it's setting the position to the 000 that belongs to the player. Next, we are going just to add the script player to the game object player. So drag it and drop it on the player. Okay, and just check that, okay, we have assigned to our game object a new component that it's our script player. Okay, now time to edit the player script. And we are going to add a public member variable, okay, that will make reference to the camera. So we will declare a public. The type of object is the type camera, okay, and the name of the public variable, it's you can use whatever you want, but I will call it my camera. Okay, so going back to the Unity editor, we are going just to set the reference to the camera by just clicking and dropping the camera on the public member variable we have just created. Okay, so now the player script has the reference to the camera. And the next thing that we are going to do is to implement the player movement. The first thing what we are going to do that is to create a new public member variable that would be the speed of movement. Okay, so we create the public member variable, public float speed, so we can customize this value from the inspector. Okay, and now we are going just to copy paste this functionality, and I will explain what's going on here. Okay, so we are going to copy paste this functionality, and I am going to explain what's happening here. First of all, this is a private method, private void, it doesn't return anything, and it's called move. This method move, what would do is to it would get the input from the keyboard to get the arrow keys or the AWSD keys, just the usual keys to move. And considering that input and the camera, it will perform the movement. The input related to up and down, we get that information from the utility input, the method getAxis, the function getAxis, because we are returning a value, and by the parameter we set the string to vertical. That would get us if the user is pressing up or down. And the parameter horizontal would do the same to get the input if the user is pressing left or right. Okay, so here we have two values, one related to the up and down and one related to the left and right. With these two values we can work with them in order to move the way we want, and we will be able to find out in what direction we move forward just by getting the axis vertical. And the camera has a property that it's called forward, that it gives you the forward vector of the camera. It gives you the exact direction where the camera is looking at. Related to vectors, this is also something that you need to explore on your own. I can provide you some links, but this is some very basic trigonometry, and you must get up to a speed on your own. So we have our forward vector that is the one that the camera is looking at, and we multiply this forward vector by the speed. In this case we want to advance 2 units every second. So we have the input that the user is pressing, we have the forward vector that the camera is looking at, we have the speed that we want to move, and since this move is going to be executed every frame, we have to adjust with time, delta time, that would give us a fraction of the second that belongs to the frame. Okay, this is related for the forward movement, but we also need a lateral movement, and the lateral movement we perform a really similar operation, but in this case, instead of getting the axis in the axis vertical, we are getting the axis horizontal. That means the input left and right, and in this case we are getting another vector that belongs to the camera, that it's the right vector. So if this one was where the camera is looking at, forward, this is the right vector 90 degrees from this one. Okay, it's a lateral vector, and again we are multiplying by the speed and adjusting with the time, delta time. Okay, so we got our forward, our lateral, so we can add the two vectors and we will get exactly the step we need to do considering the input that the user has provided to us. Okay, so we have the increment that we need to do, we have to apply it to our player, and since we want to consider the physics when we are applying this movement, we are going to apply this movement through the rigid object. Remember that previously we have added the rigid object, okay, in order for to be able to use physics in our game application. So now it's time to use that physics to move with them. So what will happen is that we just get the component rigid body of the player, okay, and we call the method called move position, like you are seeing right now. Move position moves the kinematic rigid body towards a point. Okay, so we have to specify the point in the space where do we want to move the rigid body. Okay, so we just get the current position of the transform and we add the step, the increment we want to do. Okay, the final piece of this puzzle is just to call move from the update, because we want to execute it every frame. If we have it done it right and save and go back to the editor and play, we should be able to move. Right now we are moving to a really low speed, so what we are going to do is to stop. We are going to increase the speed something higher, for example, press play and check if we like it. Okay, so if we like it, we can keep it. Okay, good. Now the final step to complete our player's movement is to be able to rotate the camera. Okay, so the first thing that we are going to do, we are going to add two variables. The first one, it's a public one. Okay, just add it right here. Sensitivity. Okay, it's a public float called sensitivity, and we will assign just a 7, and another private member variable that we will call m rotation y, that we will initialize with a 0. Okay, so next, now it's time to type this function. You can just copy and paste it, and we are going to explain it just right now what we are doing here. Again, what we are doing here is just to get the input of the user. In this case, we are interested to get the movement of the user with the mouse in order to move the camera, the forward vector of the camera. We are going to get the input of the user in order to move that forward vector. So we declare a private method, void. We are going to call it rotate camera, and let's see what's going on in the body of this method. So what we have here is camera transform will have a property that is called local Euler angles, and this value that is related to the rotation of the parent component, we will add the input that we are getting from the mouse. And to get the input from the mouse, we again are using the input utility. We use the function getAxis, and now we are getting the coordinate x of the mouse. Okay, the lateral movement. Okay, left and right of the mouse, and we are multiplying this value by the sensitivity in order to be the movement more sensible or less sensible, more faster. Okay, this is in relationship to the horizontal movement, and now time for the vertical movement. Okay, for the vertical movement, what we are going to do, we are going to use what we declared before, the private member variable that we declared before. Because we need to keep the state of this one. What we are going to do here is just to increase. Okay, this operator is exactly the same as if we were doing just like this. Okay, we are increasing the rotation by this value, and this value is we are retrieving from the input the axis on the mouse Y. Okay, we are getting the input on the mouse Y on the vertical axis. Okay, up and down, and we are multiplying this value by sensitivity to make it faster or slower, the same way we did it before. Okay, finally we are applying a clamp in order to limit this value, and with these two values calculated, we can apply to the camera through the local Euler angles the new direction where the camera is going to look at. Okay, so in short, you can use this method in order to get the input of the user's mouse, in order to be able to move the camera with the mouse. If we have done it right, and we go back to the Unity editor, and we press play, we should be able to look around and move. Okay. Okay, now one exercise that you can do is just to populate the whole area with 3D objects, and just to verify that you are moving around. Okay, just feel free to create as many objects as you want. Okay, so Okay, so feel free to experiment, to create ramps, to move around, and you would have done your first player class that you would have been able to use to move around a 3D environment. As optional homework, if you want, just explore the methods we have used, the instructions like for, conditions, just try to have a little bit of fun creating an environment that you would like to move around and enjoy.